Hey guys, today we're going to talk about lesson 5.4, and it is going to kind of cover something we already covered in chapter 3. That's going to be terminating decimals. Oh, hello, terminating. Let's try to spell it correctly. But we're also going to cover repeating. Now, we kind of talked about them before, but this is our official notes on them. Repeating decimals. Okay, so we're going to kind of talk about terminating decimals first, and then we'll do the repeating. So first I'm going to go back to a word that is super important. We've talked about it several times, and that's a rational number. It's going to lead to the next thing we'll talk about in this chapter. So a rational number starts with the word ratio. Okay, so a rational number is any number that can be written as a ratio, Why do I always want to write ration? Ration. Why do I always do that? It's so weird. Or fraction. So ratio is a comparison of two integers. A fraction is a comparison of two integers. Same thing. Okay, so what do we mean by decimals that terminate? So decimals that terminate end, let's do that in dark, end or repeat. I'm going to box him in a different color. Are rational numbers. So they're going to be part of the rational numbers. So fractions are, decimals are, terminating and repeating decimals are rational numbers. Fractions, mixed numbers, whole numbers, positives, negatives, they're all rational numbers. Next year in 7th grade, you're going to learn how to change a repeating decimal into a fraction. So exciting. So, just a reminder again, how do we convert a fraction to a decimal? So we covered that in chapter 3. We covered that in chapter 2. We take our fraction, and I'm going to kind of recolor code those two numbers. Okay, and we're going to put the 4 on the outside of the division house, down and out. And then we're going to have the numerator is underneath or in. So, in words, denominator divides into the numerator. Okay. Now, one last thing about terminating decimals. Because they end, oh my goodness, terminating decimals. If you ever watch or listen to Khan Academy videos, I'm sounding like Khan right now. What makes them terminate is they have no remainder. So you may have to, once you put in the decimal point, annex a 0, bring it down and continue dividing, but eventually you will have no remainder with a terminating decimal. Okay, so let's just do a couple of these. Directions are going to say, oops, let's go back to black. Sorry, there we go. Write each as a decimal. So we've got 4/5. So it's going to be 4 divided by 5. Now, 5 can't go into 4, so I can put a 0 up in the quotient. Then I put in a decimal point, bring it straight up into the quotient. Then I can annex a 0 in my dividend, and then 5 goes into 40 8 times. 5 times 8 is 40, and I have 0 remainder. So the answer is 8/10. Okay, try another one. Negative 8/25. So we're going to use my division house, and we're going to take 8. Now here's what's interesting. I am not going to put the sign there, but I'm going to put it straight into the quotient, into the answer. Divide by 25. And then 25 goes into 8 0 times, so then I put it in my decimal point, bring it up, annex a 0. 25 goes into 83 times. 3 times 25 is 75. I do my subtraction, and I get a 5 remainder. So I have to annex another 0, bring it down, and continue dividing. And 25 goes into 50 2 times evenly. So notice, no remainder. So the answer would be negative 32 hundredths. So big note over here is a negative fraction. A negative fraction will equal a negative decimal. Okay? All right, so that does it for terminating decimals. Let's turn our attention to repeating. Now, you probably can still fit this on the same page. Me, I've run out of room on my screen, so I'm going to go to my next screen, and we're going to talk about repeating decimals. Repeating decimals. So what is a repeating decimal? A repeating decimal is a decimal with one or more digits that repeat. I think we all know what repeat means. It's the same thing over and over again. Okay? So what we're going to do is we're going to let our audience know that this is a repeating, because we are going to use what's called a bar notation. So that's a signal that somebody says, oh, that digit keeps repeating. So it shows that a digit or set of digits, I bet some of you may not have known that. You could have like 5 repeat forever, or you could have 52, 52, 52, 52. Okay? Set of digits shows that a digit or set of digits in a decimal repeat. Okay? So here's the process we follow. So with bar notation, we're going to write the digit or digits. Write the digit or digits. Oh, by the way, what's really weird is sometimes the number that repeats isn't the first digit that comes after a decimal point. And by the way, whole numbers never repeat. I mean, whole numbers like in, before the decimal point. Okay, so write the digit or digits that repeat. Only one time. Okay, that sounds a little weird. So basically what I'm saying is that you write the digit once that repeats, or you write the set of digits that repeat only once. You don't write 0.33 with a bar over the last three. No, you write the digit that repeats one time, and then we're going to put the bar in. Okay, so then we're going to draw a bar, which is a fancy way of saying line, so it looks like this. Over the digit or digits that repeat. Only them. So you have to be super careful when you write that bar that you do not get it over the decimal or anything else that should not repeat. Okay, so let's do a couple of these and we'll be done. Directions are going to say write each fraction as a decimal, so same as before. It's the answer that's going to be weird. Oops, sorry, each fraction. As a decimal. Okay, so third example. Say we have 5/12. Okay, so we're going to do 5 divided by 12. So 12 can't go into 5. Put in my decimal point, bring it up into my quotient, annex a 0, and I start dividing. Well, 12 goes into 54 times, which is 48. When I subtract, I get a difference of 2. So I'm going to annex a 0, bring it down. 12 goes into 20, only one time. So when I subtract, by the way, that noise was my kitty cat, I get an 8. So I annex a 0, bring it down. 12 goes into 80. Let's see, 6 is 72. 7 would be 84, so 6. So I get 72. Ooh, look what happens when I subtract. I get a difference of 8. So as soon as I notice that I have exactly what I had before, nothing's ever going to change. It's still going to keep going on and on and on. So what I do is I stop. I write the numbers that don't repeat, and then I write the digit that does repeat one time only. And then I'm going to put a bar just over what repeats. So this would be 0.416 with the 6 repeating. So that would be 0.416666666 forever. Okay? All right, now I'm going to give you the worst division problem ever. Okay, not that it's a negative. I'm going to put that negative up in my answer. 7 can't go into 5. Put in the decimal, bring it up, annex a 0, and now I get to start dividing. You'll see in a minute why I'm telling you it's the worst. 7 goes into 57 times, which is 49. That's pretty close. And the difference is 1. Annex is 0. And 7 goes into 10 one time. Difference of 3. 7 goes into 30, let's see, 4 times, which would be 28, with a difference of 2. Oh my goodness. 7 goes into 20 twice, which is 14, with a difference of 6. Holy smokes. 7 goes into 68 times, which is 56, and that gives me a difference of 4. Oh my goodness. Bring down another 0, and 7 goes into 45 times, which is 35. And then we get back to 5. And look what happens. If I annex a 0, I'm at 50. So I'm 50 here, but guess what? That's where I started in the beginning. So what's just going to happen, once I get to the 50, the 7's going to go in, and I'm going to do it in a different color so you can just see it stand out. I'm going to get a 7, a 1, a 4, a 2, an 8, a 5, a 7, a 1, a 4, a 2, an 8, a 5. Okay? And so on. Dot, dot, dot means and so on. So, how do I write my answer? Well, we're going to stick to what's black and put it over here to the side. So I'm going to get negative, and then I have a decimal point, and 7, 1, 4, 2, 8, 5. I'm going to put a bar over it. So here is the on this problem. Dividing by 7. Always. Well, let's see. That's not necessarily true. If the number I'm dividing into is a multiple of 7, this won't be true. But if it's not a multiple, what I'm about to say is always true. Results in a 6-digit repeating decimal. That is the longest repeating you will be seeing. Whew. That's it, guys. Good luck with this. We'll talk about it later. Bye now.